right? This is the new syllabus content lah. And this is the syllabus requirement. Refer to it lah to make sure you have learned everything. And these are the symbols that you need to remember or recognize or memorize. Right? These are the others. Right? Potentiometer, oscilloscope, capacitor, diode, light emitting diode. Okay, we have covered. We are now on this question. What is your answer? Have you managed to work it out? 378. Yep, managed to work it out.
Potential difference? Oh, no, yeah.
You should be working it out. We have left it halfway through. I can take P as a reference or Q as a reference, then find a potential across Px and then Py, then subtract, you'll get the value. Okay, Px, the current, right? Yeah, told is 12 volt, cross here is 12 volt. So you find the current through here. Ipx is 12 volt divided by this add together 1500. And Vpx equals to Ipx times R, which is this one, right? So that one times 500, you get 4 volt. Then Py, right? Current through Py, right? The same thing. Your voltage is 12 volt, 12 volt divided by the total resistance is 300, 3000, sorry. Then times you want to find the current through here. Sorry, you want to have potential difference across Py. Then it's just this current times 2000. So you get 8 volt. Right? So it means that Y is at a higher potential, X is at a lower potential. So they are not interested in the negative sign. So we just put follow. Answer is forward. B. Okay.
Mm.
Y is at a higher potential. X is at a lower potential. How about this one? Ammeter have negligible resistance, so you don't have to worry about the resistance of ammeter. Voltmeter have infinite resistance, so you don't have to worry about the voltmeter with drawing current. The reading of meters I1, I2, V1, V2 are labeled as diagram, which is correct. Yep. What is your answer?
Oh, V2 more than V1.
So
Wait,
what's your answer? Yep. What's your answer?
B.
V1 is greater than V2. Right? You take a the total resistance of this one is 3 times 6. 3 divided by 6 is 2 ohm.
Oh yeah, it's 9. Yeah.
Uh, so the total resistance of this one is divided by 2 is 1 ohm. So the potential V1 is greater than V2. And then we know that V1 equals to 2V2. Right? Double the resistance means double the potential difference. Then you can take an example. Right? V2 is 2 volt. Then I2, which is here, is 1 ampere. Right? This will be 1 volt. 1 volt divided by 1 volt divided by uh, V2 is 2 volt. So I2 is 2 divided by 2 is 1 ampere. And V1 will be 4 volt. Right? From here, V1 is 4 volt. We just give an example. It's faster to see clearer. V1 is 4 volt. 4 volt. V1 I1 is 4 divided by 3 is 1.3. So we can see straight away I1 is greater than I2. The answer is A. Happy with that? Anything now clear?
Yeah, okay.
Okay, what's the answer for 32? Sorry, it's not complete. Yeah, we should have the complete answer, complete choice of question. Maybe we'll try this one first, 30. Diagram shows a light emitting resistor, light dependent resistor, sorry, and thermistor forming a potential divider. So this is a potential divider. Under which condition will the potential difference across the thermistor have the greatest value? Yep. Can?
C.
Okay, we'll see. You want the potential difference across here to be high. So this one should be high resistance. High resistance will be
High temperature.
this is thermistor, not
Oh,
resistant,
oh,
not resistor, So it must be low temperature. Then this
oh
one,
yeah, okay.
you want low resistance, so it's high illumination. Okay with that? Answer is B.
Yeah.
Okay, 33. Cell 2 volt, no internal resistance. There's a resistor. V1 is the potential difference between S and P. Right? V1 here. V2 is the potential difference between S and Q. Right? S is our reference point. What's the value of V1 minus V2? Right? You've just done it. What's your answer? Find the current here, lor, and find a potential difference across here. Find the current here, a potential difference across here, and subtract, lor. Okay, taking S as our reference, V1 is, right? This is the same. So it means this is 1 volt, lor. No need to calculate, lor. Sorry, meant to be hidden. Right? This one is a potential divider. So it's 3 divided by 2 plus 3 times 2 volt. It's 1.2 volt. So 1.2 volt here. Q is higher potential. So this is V2, this is V1. So subtract, lor. V1 minus V2 to get minus 0.2. Lor. The answer is C. Lor. Okay or
Mm.
not?
Yeah.
How about this one? Yep. This potentiometer for this EMF for this cell, the balance there is 0.7. For this cell, the balance there is 0.9. If the EMF of cell X is 1.1, what's the EMF of Y? Yep.
Is it B?
Boy, is it?
Yeah.
I see.
Oh, wait, no.
EMF of Y or EMF of X is 0.9 over 0.7. So it's 1.4 donkey.
Yeah, yeah,
Okay,
yeah.
this one, right? Ammeter is 1 ampere. Voltmeter is 0. Resistors and meters are re- reconnected to supply as shown in the diagram. 2. What is the meter reading in diagram 2?
Um, I think it's C.
Let's see. Right? The battery outside there can be put inside here. It's the same thing. And the voltmeter can be put outside there. So it's more or less the same thing as these two. Okay, except that the emitter is here, emitter is there, the other side. The circuit is the same. The answer is A. Can see.
Why is the voltmeter reading the same?
Okay, let's see our the original diagram. Original diagram tell you that this is current, right, 1 ampere, and voltmeter reading is 0. So it means that the potential across here and across here, you subtract, there's balance, not current flowing through here. They are the same potential difference, these two. So these two will be the same potential difference. So now I just redo the whole thing, right, to show you that these two diagrams are almost the same thing. Right? And then I put a voltmeter at where the battery was originally, and these two are the same picture. It's just that this is inverted, that's all. So it should still be the same. Yep, 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 yep.
Okay.
This one is memory work. Memory work. Yep, yep. Shouldn't take too long. If you are aware of your potentiometer, you should be able to say straight away, this is the one. Right? Two source must be facing the other side. Galvanometer in series with this one, not this one. Okay. Memory, memorize.
Okay.
This one, what's the answer? EMF is 9 volt. Reading on a high resistance voltmeter is 7.5. That means it's 7.5 across here. What's the current? Right? The voltmeter reading is across here. So that's where you find the current. No? 7.5 divided by this one. No? Yeah, V equals IR. The answer is B. No?
I got B.
Okay, good. This one, all are equal resistance. Battery of negligible internal resistance. Apply 12 watt. What's the power dissipated by the by heating What's the power dissipated by heating in the resistor R?
A.
Right? Let the resistance be R. Since all the resistors have the same resistance, the current through Q and R must be half of this one, right? 0.5 each. D equals I square R. Total power dissipated, right? I times R, I square times R here. And then same, both of them same resistance. So it's I square of this one times R, I square of this one times R, same thing. That's why there's a 2 here, equals to 12. So add them up. Right? This 1, sorry, this is 0.25. 0.25 times 2 is 0.5, so it's 1.5 squared. So I square over R is 12 divided by 1.5 is 8. All dissipated in Q is I squared, right? It's this one, square times R. So it's square of this one is 0.25. IR square is 8. Okay, A,
No.
where do you go wrong?
What do you mean? Oh, I said A.
Oh, you say A, then good. You got it right. Yeah, why I give it that? What is the answer for 51?
You want?
High resistance voltmeter connected across a battery. Have a rough idea what the picture is, or you want can draw it. A battery is connected in series to a lamp. Resistance, right? 10 ohm there rather than 15. Voltmeter reading is 5.6. Which statement explain this observation? Right? Electromotive force of the battery decreases because work is done across the internal resistor. Electromotive force is constant, never decreases.
Hmm.
EMF of the battery decreases because work is done across the lamp. Same thing, EMF is constant. EMF is constant. Only terminal potential difference decreases because there's work
I
done.
think it's C.
True. The potential difference across the battery decreases because work is done across the internal resistance. Let me just make this one smaller still. Okay, see, all right. PD across the battery decreases because work is done across the lamp. No, always done at internal resistance. That's why the PD across the external resistance decreases. I have a picture lah. Even they don't have a picture for you, they can, if you want, you can draw. How about this one? Hidden cannot see. Replace step by step, lor. Replace this one with one resistor. Then replace this one with one resistor. Right? Replace the parallel one first. Right? Remember, for identical resistors or resistance R, right? R total is just R divided by R. I know if all of them the same. So this one 4 divided by 4 is 1 ohm. No? Okay, that's how we replace this one. Sorry, hidden again. Okay, this one is 1. Right? 4 divided by 4 is 1. That one. 2, 6 of them in parallel. Divided by 2 is 6 divided by 2 is 3. That's 3. That's 6. So this is 6. 6 and 6 is 3 and 1. So it's 4 ohm. No? Answer is B. No? Can
Hmm.
each of Kirchhoff's law is linked to a conservation of physical quantity. What physical quantity is assumed to be conserved in the following Kirchhoff's first law and second law? First law, conservation of what? Right? All this should be in your by your fingertips already.
C.
Okay, good. This one? All right, we got 10 more minutes. Yep.
Is it B? Wait. No, no, no. I think it's C.
Thing is C. C is V3 equals to 2V2. As far as you're concerned, V3 and V2 are the same. It's across this one. Right?
Oh
V2
yeah, wait, I saw
is the
wrongly.
same. Assume no internal resistance. V equals to V1 plus V2 or V3. Right? It can be V2 or V3. So V minus V1 equals V2. Donkey. Okay or not?
Oh, okay.
This one?
should be B, I think.
Donkey, is it?
Yeah, donkey.
Okay, you are told that this is 4 volt, this is 10 ohm, this is 10 ohm. So you start from the slider on the potential is moved from X to Y, X to Y. So it means that it's moving from 4 volt to Y, Y is 2 volt. Right? So it should be B. Right? Okay, no?
Oh, yeah, B, okay.
Okay, let us try long question, paper 2. What is the answer for the first one? This one is testing you the formula, using the formula, that's all. Yep, can get 0.4 ampere.
Yeah, 40. Oh, yeah.
And resistance, what is the resistance? Okay, use the formula. Or R is V over I. Okay or not?
Hmm.
Okay. Each lamp has a resistance 120 ohm when cold. Before connecting the circuit to the main supply, the electrician tests the circuit by connecting a meter which measures the resistance between point X and Y. This is your X, this is your Y. The reading are so you're supposed to fill up the reading. Yep. What's the first one? All open.
You?
Overload. Cannot measure. There's no such thing as infinity.
Oh,
And open. B and C open. This one is closed. So there's only 120 ohm. And close, close, open, close, close, open. Right? So these two are in parallel. Right? These three are in parallel. So you should get 40. 120 divided by 3 is 40 ohm. But you get 60 ohm here. Then all close, you should get 30 ohm. Four of them in parallel. So the fault is here. Right? One of them is spoiled here. Can
hmm.
should be able to fill up this table. Use a computer figure suggest the fault. Right? One of the lamp in series with the switch W is 40. Switch B is 40. Right? From here, you can see, right? One of these length is 40. Okay, let's try this one. Right? So this one is using the resistivity formula. Right? Length is not given, so you cannot use that. So alternative is to use P equals V squared over R. So I'll put there, 60 watt, 3 watt, so I'll put there. Then calculate our R is 2.4. Calculate the length. So this one has to use resistivity formula. Right? Resistivity, that one there. L 2.4 is from here, 2.4. Pi R square. R square, this is in diameter. So you have to change it to meter divided by 2, then square it. Can.
Mm.
Two cell E1, E2 are connected to resistors R1, R2, R3 as shown in figure 7.1. The current I1, I2, I3 in various parts of the circuit. Write the expression for relating I1, I2, I3. Yep.
Mm.
Can.
Yeah.
I have to give you the answer because it's just 1 minute left. Anytime can switch off already. So I see you on on Tuesday.
Mm.
Any comment? We still got anytime now it will switch off. The next question is 116.